the astronomical revolution that was ushered in by Copernican astronomy. Now, before that, my introducer explained, there was the Earth-centered view. The sun-centered view was brought in by Copernicus, and we might not think that this was a very big deal. All happened is that the Earth and sun, in a sense, switched places. So there's a sense in which you might think, okay, there's this astronomical revolution. Is that really a big deal? We have upgrades in our physics all the time. Well, it turns out to be a really big deal, and we're going to explore why it was a big deal. So today's talk, though I originally titled it Astronomical Revolution, it's more accurately called the Cosmological Revolution. And this is precisely because the sort of thing that happens to us when we bring about a science is more than a new understanding of physical reality. We actually have a new way of viewing total reality, our place in that reality, and what the nature of things is. And it goes beyond just what we think the nature of the physical things are. And so when we get a new science, especially we get a new science replacing one that has been with us for a very long time, we have a total revolution in the way that we view reality. And that revolution isn't just about like what object is where in the universe. It's also what we are, what kinds of things that we are, what our place in that universe is, and kind of the meaning of the world and the meaning of life gets changed and revolted. And so goes through a revolution, so we're going to explore that. And again, questions at any point, just raise your hand and we can talk through those things. So I'm going to give us sort of like a whirlwind tour of some different astronomical, cosmological views. And we're not going to ponder them too much, but the idea here is to give us a sort of flip book image of the different sort of paradigms that we've gone through since the ancient Egyptians up until the future, and sort of imaginative theories about what the new physics will be one day. So on the Egyptian cosmology, the actual material substance of Earth, which is this bottom god, or depicted by this bottom god, is actually made of the god's body itself. Earth's substance was God's substance, and it was the particular god that's depicted at the bottom there. The heavenly substance is depicted by this heavenly god overarching the earth, and so heavenly objects are made of that particular god's essences or body. The space in between was created by a third deity which forced itself between the first two. The first two were making love, and the third god said that's enough of that and put itself in the middle, and in so doing made atmosphere, air, and space itself. So the very space is made up of a third deity's body. Now this is not merely a picture of astronomy. We do have astronomy. The stars in the skies are part of the deity's body. But it's also a picture of cosmology. What is the essence of things? What is, in a sense, the metaphysics of the objects? We're going to come back to Aristotle quite a bit. But here's the original first picture of the Aristotelian view. You see the Earth is depicted prominently in the center. You have the different planets in circles or spheres around the Earth. And then on the far edge, you have something called the firmament. And the firmament is the sphere, the crystalline shell in which the stars lived, or in a sense were embedded. So you have like a nesting doll. You know these Russian nesting dolls where you have one doll inside of another doll? That's a sort of view, but instead of Russian nesting dolls, you have spheres nested within spheres. And the very center sphere was the Earth, and as you go out from it, you get new planets, and at the far edge, you get the stars itself. This is the Aristotelian picture, and we're going to discuss it more in detail as we go forward. Oh, by the way, usually when we draw pictures and we have to label the image with north, west, east, south, we usually put the east on the right side, but in all of my pictures and all the sort of images we'll see, east is actually on the left. So just remember that. I'll say something rises from the east and then sets in the west. It's rising on the left here and then setting on the right. At least this is how we're going to picture it.
Why?
Why what?
Why is on the left side?
It does. It's a convention. It doesn't matter which way we orient it. The reason why we chose to do, I put east here, is because I'm going to show some images, some videos. And these videos assume that east is on the left. And in order so that we don't switch conventions halfway through the talk, I'm going to keep with the videos convention I can't change the video, but I can change my picture. After Aristotle, 400 to 500 years after, Ptolemy came along and he adjusted Aristotle's view. What he did was he made it more complicated. Not only are planets in spheres around the Earth, but they're actually on tiny spheres within the spheres. So if you look here, and I'm going to get tangled up in this, I'm certain. What you have is Jupiter not only follows this line of orbit around the Earth, but it also follows this line of orbit. We call this an epicycle. And as time goes on, what it will look like it's kind of spiraling. Right? Ptolemy did this in order to get the data right. Aristotle's view was a little too simplistic to meet our observations. Well, it turns out it's actually quite a bit more complicated. Once you add in all the sort of different epicycles and the different sort of mathematical tricks that you need to add to the system to make it match our observations, it's going to look very different from Aristotle. It's going to look rather cumbersome and heavy. People ended up not liking this, and so they went for Copernican system, which was again supposed to be simple. Brings us back into nested spheres, at least that was the promise. Here, though, you have something very different, something that you might miss on first glance, and that the Earth is no longer at the center. The Earth in this picture is the ball up there that's actually rotating around the sun. This seems like a small change for so great advance in simplicity in our picture, but it comes with a high conceptual cost. Moreover, turns out Copernicus wasn't so simple. You also have to add all these tiny little epicycles in his picture to get the data right. Right here, again, we're just going through a flip book history of the different cosmologies that sort of intellectual culture has adopted at different points. Today's talk is really going to be focusing on these two, comparing these two astronomies and the related cosmologies that are affected by them. If you want me to go slower to take any pictures, if I go too fast, let me know. A third view that we're not going to talk about was Tycho. Fascinating view. He took Kepler, which is supposed to be, sorry, not Kepler, Copernicus, which is our new astronomy, and he took Ptolemaic view, and he coupled them together. He, in a sense, married them. He did so because he was able to keep the Earth at the center, and in order to get the data right, what he said is the Earth is at the center, the sun is rotating around the Earth, just like we're going to see in the Aristotelian and Ptolemaic view. Earth is at the center, sun is rotating, but the novelty is all the other planets rotate around the sun. So everything rotates around the sun, except for the Earth, and the sun rotates around the Earth. People like this. It solves some conceptual issues. It ended up not being adopted. Brahe, Tycho Brahe was the one that came up with the previous view. One of, in a sense, his students, or the person that he gave his data to, he was a very good astronomer, was Kepler. Kepler was going to come up with a new cosmology astronomy as well. And he thought he would do it by nesting spheres inside of geometric objects, perfect geometric objects. Turns out this actually didn't work. This was his first try. He gave up on spheres, and he went with elliptical orbits instead. And this is more like the view that we have now. So we're getting further and further away from the bodies of gods, the deities, and closer to something that we now recognize as something looking like what we were taught in high school textbooks on physics. Whatever you wish, whatever they wish. We don't stick with this, because on this view, the cosmology is actually still finite. We weren't picturing a very large universe. We were imagining up until this point in time a universe large enough to get the data right, and it was still something of finite size, something that you can get to with a rocket ship within the lifetime of a human being. We know now, well, I'll get to that in a second. Descartes. Descartes thought the universe was filled with a kind of fluid, and all the objects were stuck in this fluid and rotating around suns. So for Descartes, there wasn't just one sun. There are many suns. This is the sort of view that we have now, where we don't think the sun is a unique kind of object. We think it's just one star amongst many. Descartes also had this view, but he had this idea that there's all this fluid, and planets were stuck inside that fluid and were forced to orbit around, kind of like in these vortices around suns. We ended up not accepting Descartes' view for various reasons. And this is closer to a view that we have now. Maybe we could dim the lights for this one so we can see it. Here, the universe is much, much greater. Whereas we're moving forward in time, the universe is getting larger and larger and larger, and isn't becoming what's called a, in a sense, there's going to be no boundary to the universe as we move into modern theories of cosmology. This is something like we have now. Things are on elliptical orbits, but they're not on the same plane. You see how some orbits look like this and other orbits look like this, so they're getting more complicated. And not only that, the universe is getting massive. So our Earth is not super close to the sun. It's pretty far away. We're way over here. And the Milky Way is extremely large. And the Milky Way is just one amongst a number of galaxies in the universe. So the universe has exploded in size from the time when we imagine the universe being composed of a God's body under us and a God's body over us. Not only that, now we have to think, what is the future physics pointing to? The future physics keeps getting bigger and bigger. Not only are we in a very large solar system, but that solar system is in a very large galaxy, a very large universe with many, many solar systems and galaxies. But it might be the case that there are many, many universes altogether. So things like string theory and these different physical accounts where you have multiple universes all comprising physical reality somehow, and we happen to be in just one of these bubbles. Do we know this is true? Surely not. But these are the sorts of things that physicists are toying with, the ideas for what the next physics of our cosmology is going to be like. Not only that, not only is the universe getting big, but the actual fabric and material of space itself is being explored and being given new sort of descriptions. Before, we used to think space as being something kind of like a continuous material or environment that we get to interact with. Well, certain quantum theories of gravity speculate that the actual material of space itself are these discrete foamy chunks of volume and area. So rather than this room being a continuous volume, it's actually produced by small little bits of volume that are all jumbled up together. And it's only by being jumbled together, these bits of volume, in the right way, that we have something that looks like space and time. But at the very beginning, before the jumbling, you have just all this volume of material, of pieces of space that don't themselves comprise space. So this is, again, an imaginative look at what the future of our cosmology might be like. Not only might there be multiple universes, but the fabric of those universes itself might be quantum mechanical bits of material or bits of volume. So we're going way back in time now. We're going back to the first sort of big break with traditional ancient astronomy, and we're going to talk about the cosmological revolution that it ushered in. So this is a story about cosmological revolutions. And if you notice here, I put the Earth upside down. This is a story about the world turning upside down. This is a story where the world stopped making sense. This is a story in which the inconceivable became conceivable. Now, I will reference this slide towards the end, and this phrase, the inconceivable will become conceivable. And that's kind of a lesson for us when we think about what the future of science is going to be like. It will often tell us the world is going to be some way, and we're going to say, that is insane. There's no way the world could be that way. That is inconceivable. The history of scientific revolutions is the history of us as mankind saying, that's inconceivable. The next generation saying, meh, that seems pretty conceivable to me. So the history of our revolutions is a history of us changing our mind about what makes sense and what's conceivable. Now, we're going to start with what it was that the ancient Egyptians and the ancient Greeks were able to observe. And we're going to use the basis of what they were able to observe to build, to sort of influence or motivate the sort of astronomy that they developed. One thing that they were able to observe is that the stars appear to move from east to west. So remember, east is going to be on my right for the sake of these pictures. And as the night sky moves on, it moves to the west. This is the same thing that the sun does. Rises in the east, sets in the west, and the stars follow the same pattern. If you look off into the horizon, a certain constellation will come up over the horizon. It'll move, or if you watched it during the night sky with a telescope, it'll move across and it will set into the west. This is something they were able to observe. The moon also appears to move from the east to the west. The sun appears to move from the east to the west, as we know. Something else they noticed. They noticed as they recorded what the constellations were doing in the sky, that they didn't change. Year to year, the constellations kept their rough relationship to one another. Orion was a certain distance from some other constellations, and this didn't change as generation and generation observed this. And this is in stark contrast to what they observed on Earth. Though the fall and the autumn and winter and spring came regularly, the events that happened in a man's life were rather chaotic. Life on Earth was transitory, where the heavens were somehow untouched. They were eternal. They kept their motion and they kept their essence without being affected by time. Time went on and they remained the same, where things on Earth were going through rather a lot of transitions. So they marked this difference and they said, what is it about the heavens which make them eternal and unchanging? And what is about the Earth which makes it rather transitory, mutable? So you use this word mutable. To be muted or mutable means changeable. The heavens were immutable, unchangeable, or they did not change. Not only did that, they looked and they realized that certain suns or certain stars never set. So you look over at the North Star, and a certain band of stars throughout the nighttime, so you just watch it overnight, certain sets of stars never set. They just keep going in a circle around this point. Other stars will rise in the east and then set into the west, but these never set. And so the question is, what is it about these stars that never set? And what does it mean about them that they don't set? Is there something special about these stars? I surely do. I don't have this tangled in this cord. Okay, oh nice. All right. So these are the different cosmological observations that the ancient Egyptians and the ancient Greeks were able to make. However, things got more complicated. What I just explained was roughly the foundation of what Aristotle used to build his astronomy. Then we're going to talk about that. But as they made more and more observations, they realized the story was actually rather more complicated than what they just observed. So they're taking detailed account of where every star in the sky was day in and day out. You know, these were professional scientists in some sense. And what they noticed is that though it is true that day after day the planets, what they ended up seeing is that day after day the planets moved slowly to the west. Let me explain this. Let me go to the next dot here and then I'll come back and explain it. So nightly, the planets, they rise, they rise from the east and they set in the west. So what they did is, right now we have a pretty clear distinction between a planet and a star. But back then all they had is like bright spots in the sky. And they saw that some of these bright spots changed their position. Where the vast 99% of them didn't, a few of them, over the course of a year, started to wander. And they moved a little bit and a little bit. A little dot used to be right next to Orion. A month later, it's much further away from Orion. And a little after that, it's much further away from Orion. In a sense, it kept getting behind. Orion kept moving forward, and day after day, it was a little bit more behind Orion. And they said, what is up with these wanderers, is what they called them. So the original term for a planet was just a wanderer, a celestial being in the sky which wandered. What they end up doing, they end up associating these wanderers with gods. These gods have autonomy, and they have some ability to move around in the heavens. In any case, they couldn't just say all the stars or all the heavenly objects rose in the east and went to the west. Because if you look at a planet over the course of a year, it slowly, over the course of a year, is moving to the west. It's getting behind the stars. We're going to see a picture of this in a minute. So nightly they rise in the east and they set in the west, but over time, over the course of the year, they are moving backwards with respect to the stars. And they all wander up and down. So not only do they get further behind, they kind of do this little wiggly motion, okay? Or they kind of go up and then they kind of go down and they kind of go up. So it wasn't merely that they're getting behind, but they're actually changing in a sense in terms of the up and down direction with respect to the stars. They had a couple of wanderers, what they identified as the sun was technically a wanderer, the moon was a wanderer, what they named Mercury, Venus, Mars, Jupiter, and Saturn were wanderers. So they've had to somehow explain this. Now let's go back to the ancient Egyptians. The ancient Egyptians didn't have all the data that the ancient Greeks did, but with the data that they had, they came up with a certain sort of cosmology. Now this is where cosmology enters in. It's not merely what the stars are doing, but it's a sort of metaphysics about what the nature of the objects are. And they said, well, the sun is actually a god named Ra, and every morning Ra would be born, and every evening Ra would die. So the rising and setting of Ra was really the birth and death of a god. So this is why it's more than just astronomy, it's cosmology. It's the overall view of reality. The stars are gods, and some of the stars are deified persons. So if you lived a good enough life and you knew enough of the magic words going through the underworld of the ancient Egyptians, you can gain access to eternal life. And your eternal life, you would be one of those stars that never set. So remember those stars around the North Pole, the North Star, how they just circled? If you gained sort of entrance into eternal life, you would be a deified god, so to speak, or a deified person with the gods in that aspect of heaven that never set, i.e. you would never die, you had eternal life. Some stars are eternal, as we noted. The different constellations were identified with certain deities or certain deities' powers. Aristotle comes in and he says, before was the ancient Egyptian cosmology. We're going to transition a little bit to Aristotle's cosmology. He is also going to give us a description of what are the essences of the objects. The ancient Egyptians said the essences are the gods themselves. The powers in the world are due to the powers of the gods. Aristotle was a little bit more naturalistic than this, but still metaphysical. He said that there are 5 elements to reality, and these weren't deities' bodies. These were just basic natural elements. One of the elements is air, second fire, water, earth, and ether. Now, 4 of these elements have as their essence a particular kind of motion. They either moved up or down with respect to the center of the earth. So if you were an object made completely of earth essence or earth material, you would sink to the center of the earth. If you were water, you would also sink to the center of the earth, but at a less great propensity. In a sense, you have less strength towards the center of the earth than earth does. So if earth and water are fighting as to who's going to get to the center, earth would win and push water on top of it. Earth has a greater propensity to the center of the earth than water, so in competitions, earth wins out. This makes sense to us. We usually talk about this in terms of density. Earth is more dense than water, and this is why there is, under the sea, there's actually just earth. Fire and air have the opposite propensity. Their propensity is away from the center of the earth. So the more fire element you have in you, the more likely you are to rise to the outer edge of the earth's realm. The more air you have, you also have a propensity to rise, but less of a propensity than fire. Now, all the objects on Earth are somehow a composite of these 4. So you hold a volume of lead in your hand and a volume of wood of the same volume, and you notice that the lead is trying to get to the Earth much more strongly than the piece of wood is trying to get to the center of the Earth. Why? Because there's more earth element in the lead, or that was the suspicion, where wood has some more like water or air mixed into it. So you mix up these elements and you get different kinds of objects. If there were no dynamics, if there were no interventions, what we would see is we'd see the earth at the center, all the earth elements would force themselves to the center. So we'd see just a sphere of earth, and then we'd see a ring of water, and then a ring of air, and then a ring of fire. But we don't see that. And we don't see that precisely because somehow all these elements are being mixed up continuously. And we're going to see how and why that happened under the Aristotelian view. Again, does anyone want me to re-say anything or explain anything so far? So I'll go here.
What's
Ether is the fifth element that we haven't got to yet. It's a surprise element. So we'll get to it right now.
No, you said the air and fire were above. Which one was above, the air? Or
The fire had the stronger propensity to rise than the air. So hot air balloons are filled with fire, and that's why they rise. And they're able to overcome their earth elements that are pulling them down, so to speak. What is the ether? The ether is what's called the quintessence. So if you ever heard this word, I don't know how it's translated in French or in Arabic, quintessence is the fifth element. And it's not even a special word. It's just saying the fifth thing. The quintessence is a special element, though, and it has an eternal property. It says the objects, anything with a quintessence, rather than moving up or down with respect to the relation of the Earth. So remember, all the other four either moved towards the center of the Earth or away from the center of the Earth. The quintessence circles the center of the Earth. And so if you're made of quintessence, your natural motion is to go in circles. Okay, so what do we know goes in circles? You know, the planets and the stars. They are made of quintessence. That's the first thing that's special about them. The second thing that's special about them is that they're unchanging. This is the heavenly substance itself. It is immutable, unchangeable, and eternal. So if something is made of the quintessence, it is eternal, it is immortal, it lasts forever, and it's unchanging. This is why the gods themselves live in the heavens. They are made of quintessence under the sort of Greek Aristotelian view. As I said, these different elements explain the natural motion of objects. Now I'm going to list these two things, and I'm going to show you the picture that describes them. I'm going to say the planets are locked in, and I'm going to say the stars on the outside are on the outside and they spin. So let's look at this picture. This picture, you've got Earth. This is actually more of a medieval picture than Aristotle's picture, but we're going to use it for the time being. You've got Earth here, and it's a mixture of fire, air, water, earth. And then you have these crystalline shells. So I'm going to call them crystalline because they're made of the fifth element. And on them is the moon, or it's Mercury, or it's Venus. The planets themselves are locked inside of these crystalline shells. They're not just rings, but remember, they're like balls nested inside of balls. Shells inside shells. And the shells are made of crystal, unchanging, immutable, quintessence material, and the planets are just like nodulars. They're just like focused sources of this crystalline material. That's all a planet is. You move to the outside and you have the zodiac, where the different constellations live, where the different stars are located. So your outside, so every sphere corresponds to a different planet. So you got the sphere of or a different wanderer. You have the sphere of the moon, and then Mercury, and then you go all the way up to the zodiac. And on this medieval picture, there's actually this outside sphere called basically the first mobile. It's the thing that ends up turning everything. We're going to ignore that for the time being. But the stars themselves sat on the outside shell, and they were made of quintessence material as well. The outside shell, whether it's this ninth sphere or the sphere of the stars themselves, different people had different opinions on this. Whatever the outside shell is the one that spun. And as it spun through something like friction, all the internal spheres on the inside, kind of like a gear of a clock. You turn the big master gear, and all the other small gears that are touching it end up turning as well. So you spin this outside shell, and all the other ones on the inside spin. And eventually, you're going to get the moon that's spinning. And the moon is spinning in somehow correspondence with the other shells. Now, under the Aristotelian view, the different shells spun at different rates. The outside shell moved most swiftly, the sphere of the stars. And this is going to explain some of the things that we see. Why certain planets got behind? Well, they got behind because the outside shell is moving faster. So the planet's moving slower. So if you're looking at, let's say, Mercury, and Mercury is moving kind of slow in comparison to the stars, over time, Mercury's going to get behind. The stars are going to pass Mercury, so to speak. Moreover, let's see what I got on the next slide before I say it. Yeah, I'll say it down here. So what this did was, Aristotle had a job. His job was to explain what it is that we observed. We observed the certain motion of the planets. We also observed the motion of the stars. We saw that the earth was rather mutable and changeable, whereas the heavens were immutable and eternal. And he had a job to try to explain this. And his explanation was a mixture of physics and a mixture of metaphysics. He was able to explain the apparent rotation of the stars, the sun and the moon. He was able to explain the apparent rotation of the planets. And I put the word kind of there, because we're going to see there's going to be a problem. A problem that it took Ptolemy, or that Ptolemy tried to solve. Question in the back.
We're making the assumption that the Earth is a sphere.
Correct.
But at that time, was it taken as such?
Yeah. Yeah, they had, not only did they know that the world was roughly, well, they knew that the Egyptians knew that the world wasn't flat, and they had arguments that it had to be a sphere itself. So one reason that they knew that the earth wasn't flat was that when they looked at ships coming in from sea, they could see that the mast of the ship showed up first, and then slowly the ship rose so you could see the rest of it. So they had certain observations like this that told them that the earth was somehow curved. They ended up arguing, especially in Aristotle. Aristotle gave arguments that the earth has to be a circle, a sphere itself. Other questions? Good questions, so. Now, the bonus is that we then have a sort of a physical foundation for astrology. Now, the difference between astronomy and astrology at that time was not clear. I'll say it now. Astronomy in today's language means the study of the location of the planets and the stars in the sky. It's a sort of a physical science, where astrology is how it is that the location of the planets affect our lives. If you are born when Mars is in the sky, then somehow that means you're going to be a warrior of some sort, because Mars was the god of war. So astrology was a study of how the planets affect us on the earth. Now, under Aristotle's view, he had something like a physical foundation for why we might think astrology is the case. The moon, by the way, this picture is terrible. You probably can't see at all what's going on here, so I'm going to ignore this picture. But let's go back. Let's see what the next one. Yeah, let's go back. The moon is spinning. And it's spinning, and what does it touch? It touches the elements of the earth. It touches air and fire, and it churns it up, right? So it's churning. So think about if the moon wasn't spinning, you would just have all the elements of the earth elements in these rings. You'd have, as a sphere, the earth is the center. All the earth elements would have sunk and solidified in a sphere. And then you'd have a shell of water, and then a shell of air, and then a shell of fire. But here you have the moon spinning really, really fast and spinning and turning everything up. It's tumultuous, and it's mixing all the elements. So the elements are mixed. You and I are of mixed elements precisely because the stars are spinning, and that causes the moon to spin, and that causes all the elements to be churned up and mixed. Now, given this sort of picture, it's not hard to imagine then that what the planets and the stars are doing is affecting us on this earth. How they're spinning determines how things are being mixed. How they're spinning determines how things are being mixed when your child is being conceived or born. Where the planets and the constellations are in the sky is somehow correlated with the sort of mixtures of elements that your child itself is gaining. And so they said, well, of course the outer stars affect us. We just now need to study what those correlations are like. Not only that, but they noticed very strong correlations. They noticed correlations between what the tide was doing and the phases of the moon. Strong correlations between tide and moon. What's the cause then? The moon, presumably. Strong correlations between, well, different things. Seasons, for instance. You have a particular season always when certain constellations are in the sky. And so they said the constellations must be the cause of these things. Now, we're zooming forward a little bit. So I'm going to take a second. We had Aristotle. Aristotle ends up having some problems. 500 years later, you have someone called Ptolemy come up with what ends up being the definitive view of ancient astronomy. Now, we're not going to talk about Ptolemy right now. What we're going to do is we're going to zoom past Ptolemy, and we're going to talk about the Dark Ages. In the Dark Ages, Europe and Rome lost Aristotle, lost the ancient Greeks' material. The ancient Islamic philosophers and theologians had it, but the West did not have it. So when we talk about the Dark Ages, we're really talking about the Dark Ages in the West. Rome lost a lot of its libraries, a lot of its books, and a lot of its education. Eventually what happens is, through the Islamic philosophers and theologians, they gain back Aristotle, they gain back the ancient Greeks, and they gain back Ptolemy. But they gain Aristotle and Ptolemy at the same time. They thought they were contemporaries. They thought Aristotle and Ptolemy were just two scientists, friends that worked together, and they didn't realize the 500-year gap between them. Ptolemy was a mathematician and a scientist first. His cosmology, his astronomy that he ends up developing, remember the circles within circles, the epicycles, very complicated. And the medieval philosophers who were getting his work did not feel up to the challenge of translating him and understanding him. Aristotle, which was a simpler version, was much easier. And we had really good translation from the Islamic philosophers. So they used these translations and they started to incorporate Aristotle first. So what we're going to do is we're first going to look at Aristotle, how Aristotle influenced the medieval world. And then later on, we're going to look at how much Ptolemy did. So we're going to do this in 2 steps. And the sort of title of this part is Trees Taking Root. And I'm going to explain what this phrase means as we move forward. So the medievals, though they got both Aristotle and Ptolemy at the same time, they really incorporated Aristotle first and started incorporating his thinking as a foundation of their worldview. This is when they're starting to build a sort of cosmological worldview. That part of the world, ancient Europe, was largely a Catholic and eventually a Catholic Protestant state. And what Aristotle ends up saying about cosmology coheres well with their prior theological commitments. Aristotle said, heaven is a place of perfection. And the Christians said, yeah. Not only that, but earth is imperfect. And earth is immutable and changeable. It goes through death and cycles. It lacks something that heaven has. And the early Christian church says, yeah, that's exactly right. Heaven and hell, not only that, were close. So this is a sort of modification of Aristotle. What the ancient medievals said is they said, heaven is literally up there, and hell is literally down there, and earth is this halfway point between them. And you and I have a choice. Are we going to climb or are we going to fall? Right? And our relationship to eternal destiny was a relationship of geography. Was a relationship of where you're going spatially. Are you going spatially up or spatially down? Heaven and hell did not merely have spiritual realities, they had a geographic reality. Heaven and earth were near, literally near. You can get to them, so to speak. Now, you couldn't really get to the crystalline stuff because it was unchangeable. You couldn't put a rocket through it, right? Because then you would have to change it. So you really couldn't get into that realm because material substance can't get into the crystalline stuff. At least that was the idea. But heaven and hell became very close and apparent. It made sense of why God is up and the devil is down. Angels are made of crystalline material. They are immutable and perfect, like God. Angels which are fallen, where do they fall from? Well, from up. And they fall down, right, into the earth. It makes sense. And it makes sense of man's struggle with his own nature. Now, if you read Dante's Inferno, the Divine Comedy, you'll end up seeing a sort of cultural manifestation of this cosmology. Dante is, in a sense, describing kind of what the cultural milieu thought about cosmology. According to Dante, there are 9 levels of hell. Under the Aristotelian view, the modified ones that the medievals used, there were 9 levels of heaven. So think about the different planets. Okay? You have the moon, you have the planets, And then you have the sphere of the stars, and then they had this last sphere that has to do with motion, like what's causing the motion of it all. So they had 9 levels of heaven, and they said, well, how many levels of hell should there be? Dante says 9. To mirror the ascent upwards is mirrored in the ascent downwards. Man can climb or fall. We of all creatures have a choice. You can choose what kind of destiny you're going to have. You can choose what kind of essence you'll end up having in the afterlife. Now, Aquinas, one of the early church fathers, he is trying to give a voice to Christian theology, a theologically grounded voice, especially in the medieval philosophy tradition, and he does so by incorporating Aristotle. So he says, look, Aristotle they loved Aristotle. He wasn't just a philosopher, he was the philosopher. They didn't even refer to him as Aristotle. They referred to him as the philosopher. Okay? So they loved this guy, and they scaffolded Christian theology on its back. They gave it a sort of philosophically robust account by incorporating Aristotelian philosophical ideas. Now, not everything meshed. There were certain things in Aristotle that conflicted with their theological commitments. Some of those things had to go. So I say anti-A. What I'm saying is there are some things that were anti-Aristotelian. Aristotle thought that it was impossible for there to be a void. We don't need to worry about this. I'm just bringing this up as an example. A void is a region of space with no material or energy. And Aristotle said this is a contradiction. You can't have this. And the early Christians said, sure he could. God could do anything he wants. Okay, so they said Aristotle was wrong on that point. So they weren't wedded to Aristotle 100%. They're willing to reject Aristotle if they thought they had good theological reasons for doing so. However, they were also willing to modify their understanding of Scripture if Aristotle suggested that they do so. So there's some passages in Genesis where, so I say pro-A, what I'm saying is pro-Aristotle. They said, look, Aquinas said, there are some things in Genesis, which in the way that the earth was structured and created, which don't really make a lot of sense with respect to Aristotle. So we have to kind of read those passages of Genesis non-literally. And he gave arguments for it. We can go over what those scriptural passages are at another time. The point is that there was something like a give and take. The early Christian church was trying to build a sort of philosophically mature theology. They used Aristotle to do so. Aristotle's theology or Aristotle's metaphysics is explicitly tied up with his physics, with his astronomy. So when they build their worldview, the early medieval church, or really the early medieval society, they're building their worldview on the scaffold of Aristotle, and part of that is in astronomy. So I said earlier, the title of the previous section was Trees Taking Root. That the tree of Aristotle is planting itself in the medieval Europe, and the roots are reaching into their conceptual structure. It's not just a physical theory anymore, it's affecting the way they view theology and philosophy as a whole. And this always happens with our science. Science doesn't live in a realm of scientific thinking. We think about the world, and all of our concepts are jumbled together, some philosophical, some conceptual, some metaphysical, and they all influence each other. So let's go down. They ended up discovering, so they had Aristotle, they loved Aristotle, they got around to reading Ptolemy, and they realized that Ptolemy was pointing out all these problems with the Aristotelian view. And this is going to require them to change their own view of Aristotle. So they started reading Ptolemy, and they said, oh man, this guy has a new modification of Aristotelian astronomy. What does that mean about our theology and philosophy and metaphysics that we've built off of the back of Aristotle? So, trees that bear bad fruit. What do you do with them? Well, presumably you don't harvest that fruit, and presumably they get chopped down. So, one problem is retrograde. This is a problem that Aristotle had, and Ptolemy says, look, we can't keep using Aristotle's fixed sphere view given the problem of retrograde. So I'm going to talk to you. And so he came up with a view that was an attempt to try to be as Aristotelian as possible while still being able to explain what I'm going to call retrograde motion. So the idea is Aristotle predicted that planets would do something. And they observed that the planets didn't do that. So they needed to upgrade the sort of model to make it match our observations. And this is what Ptolemy tried to do. So now, this is something we said earlier. Day after day, the planets slowly move towards the west. So nightly, they rise in the east and they set in the west. But over time, they're moving backwards with respect to the stars. Okay? That part, Aristotle, some Aristotelians were able to kind of figure out why they're moving backwards. But they couldn't get what we call retrograde motion, and that's this. So east is over here, west is over here. Now, as I said, this image you're about to see, it's a GIF, it's a moving image. It's an image of the planets over the course of a year. They take a shot of the sky every night for a year, and then what you're going to look at is you're going to look at how are these really bright dots changing with respect to the constellations. So this isn't a night sky shot. This isn't what the stars are doing in a single night. This is what the stars are doing over the course of a year or half a year. You're going to see that these two are wanderers, planets. Not only do they have their normal, they're getting behind. So what you're going to see is you're going to see them get behind. Everything over the course of a night is moving from the east to the west. But over the course of the year, these things are going to get behind. They're going to go slower. Aristotle knew about this, or at least his contemporaries knew about this. But what you're going to see is, you're going to see not only do they go backwards, but at one point, they go in a circle. They do this loop. And no one had any idea why they were doing a loop. So let's look at that real quick. So they're doing their normal backwards rotation. They're getting behind. And then they say, no, we're going to speed back up. And then they're like, no, let's go back again. Okay? And almost all the planets have this weird retrograde motion. And no one had any idea of why the planets were doing this weird back and forth motion. You can't explain this if all the planets are stuck in a shell, just moving like this. You don't get this back and forth rotation. Ah, we're getting there. Okay, so Ptolemy says, all right, let's say that they don't just live on a shell. Let's say they live on two circles. One circle that goes around the Earth, and then a small circle that goes around its own orbit. Okay? And what I mean by goes around its own orbit is the center of this orbit is going to move like this around the circle. But the planet moves around another circle, like this. And we're going to see if this is true, can we get the back and forward rotation? So we're sitting here on Earth, and we're going to look at where this planet is. This planet looks like it's to the right of this star. And over time, it's going to go slower. It's going to get behind. So over time, it's going to get behind this star. And eventually, it's going to get behind this star. And eventually, it's going to get behind this star. But then it's going to do this weird back and forth rotation. So we're going to see, can we reproduce the effect of this wiggle using something like elliptical or these epicycles?
So how long it would take going and coming back?
Different stars or different planets, different lengths of time. A month, a week, some of them a great period of time, a year, I don't know, a year, long times, yeah, depending on how far away they are in comparison to the Earth. So let's look at Ptolemy. This is what Ptolemy says. If there's a wiggle in the planet, an epicycle, you can explain it with the epicycle. So Ptolemy says, look, you put them on epicycles, and I could explain retrograde motion. And everyone was like, hooray for Ptolemy. Let's modify Aristotle. Let's get away from the crystalline shells, so that way we could actually have a physics which explains what we see. So here's the two images together. This on the left was the one that we saw earlier, where it has the retrograde motion. Here's Ptolemy's explanation of it, where you've got the wiggle back and forth. Okay. And people liked it. So this was a problem, though. This was a problem because the early Christians built their metaphysics on the shells, on there being an order of the planets, and of the shells being of a crystalline element that is unchanging, because that's where heaven is, right? The second problem with Aristotle is the calendars that you make using the Aristotelian system are way off. You pay attention to them for 2 or 3 decades, and you have to adjust them by hand. They no longer are mapping the actual seasons or where constellations are in the sky. Why is that? Well, because Aristotle was wrong. He didn't have a bunch of the sort of astronomical tools that we need to actually model where the planets are. But the early church and any religious tradition wants an accurate calendar because they base religious holidays off of a good calendar. So the early church was said, look, we can't be using Aristotle's system as an actual depiction of what the planets are like because we can't get a good calendar to describe when all the religious holidays are. So we need to upgrade ourselves. We know that Aristotle's not working because of the retrograde motion. Something like Ptolemy is better. Ptolemy gives us good calendars, but even Ptolemy wasn't given a good enough calendar. Ptolemy was still giving calendars that were getting things off by a few days or a week. Not only that, but these were strange constructions. When they got Ptolemy and they said, wow, you're telling me that the universe is like this, where not only do you have a planet on a circle, but sometimes you have two epicycles. You have a planet on an epicycle, which is on an epicycle, which is on an orbit. And sometimes these planets don't even circle around the object. They circle around a point in random space next to the object. That way they can get the whole thing to wiggle. Okay, so they had to come up with all these what we call ad hoc constructions to get the sort of model to work. And people were getting a little fed up. They said, look, this is getting a little crazy. You want me to do epicycle on epicycle? How about we just have a new system? How about we have a new cosmology that will get the data right? Not only that, but there are conceptual problems. The shells are supposed to be epicycles. Epicycles are supposed to be made of a quintessence material that is unchanging. But how do you have an epicycle within a shell? If you have an epicycle within an unchanging shell, that means a piece of that shell is changing. It's going in a circle like this. So can the shells be made of the quintessence, a perfectly unchangeable element? Presumably not. Not only that, but you don't have any mechanism. The original motivation was that you can put a sphere on the outside that spun all the other ones, and there's like teeth of a clock that like turned, and you were able to explain all the mechanisms of the heaven, kind of like a clockwork. You had a mechanistic explanation, but you really don't have that when you have 1,000 epicycles, where they're all spinning with respect to one another. And no one made an attempt to provide an overarching mechanistic explanation for how all these epicycles are supposed to work. It was just a mathematical description without any physical theory explaining it all. Well, this was their concern. So the point is, at this point, they said, look, we've got to really undo our commitment to Aristotle, but Aristotle had already sunk its roots into the conceptual fabric of early medieval Europe. To rip up a tree, you have to rip up all those roots, and this causes conceptual pain and trauma. And this is why the Astronomical Revolution is a cosmological revolution. It's because the roots that have sunk down into the way we conceive reality are being ripped up. And with it, every aspect of our culture that was touched by it is being modified. And we're being asked to rethink our commitment to theology, to philosophy, to the way the government gains power or authority. Everything was affected when you've based your theory on Aristotle, and Aristotle is now being shaken. All right, what time is it? This is correct? So I probably won't have time to talk about this arrow here, but there's a problem with projectiles. If we have time, we can come back to it. This was another problem with the Aristotelian view that the early medieval philosophers struggled with, and they came up with a solution for. Aristotle couldn't explain how projectiles worked. Okay? You and I might think, well, that seems like a silly problem. Why couldn't he figure out how an arrow worked when you threw it? Okay? But his physics didn't give him the tools to do so. We won't talk about the solution exactly, but I will mention the solution, and we can come back to it. The early medieval philosophers solved it for Aristotle. They weren't afraid to tweak Aristotle when they needed to, and they said, there was this thing that objects had called inertia. Now, inertia you could think of as something like momentum, or you could think about it even as, in the medieval conception, it'd be better to think of it like as a battery of force. When you throw an object, it keeps a bit of that force around with it, and it's able to use that force. like a battery, to keep it moving in a particular direction. So the medievals came up with this new concept. They never had a concept called inertia. They generated this concept in order to explain things. This concept, inertia, ends up being the foundation or one of the backbones for the Copernican revolution. Copernican revolution is supposed to be a revolution in science, our understanding of astronomy. But it utilizes a prior conceptual revolution, this idea that there is this thing called inertia, which came about through a conceptual analysis by philosophers. So I'm bringing this up amongst other things to show that what was happening in the culture of medieval Europe was laying a foundation for the revolution. And that revolution both did not only have physical effects, it had cosmological, philosophical, theological effects, but the precursors for it weren't merely anomalies in the physics, i.e. what encouraged people to go through with the physical revolution wasn't merely the fact that the physics wasn't getting things right, but they gained new conceptual tools which allowed them to conceive of a new physics altogether. What the medieval philosophers did was provide them with the conceptual tools to put the earth in motion. Before this, they didn't have the right conceptual tools to make sense of an earth moving. With a concept like inertia and some other things, they were able to put the earth in motion and for it to make conceptual sense. So again, we're putting the east on the left here. Copernicus said, okay, look, Ptolemy, we don't really like it. It doesn't even keep with the sort of Aristotelian tradition that we've fallen in love with. So why don't we just do this very simple thing, put the earth in orbit and put the sun at the center. If you allow me to put the earth in orbit and put the sun at the center, I can return you to something that looks more Aristotelian, where you don't have all these epicycles, and I can give you better calendars than Ptolemy ever could. So this was his selling point. The problem with Copernicus is that it wasn't so simple. The first thing is, you say, Copernicus, the earth doesn't move. Just look, it's not moving. How can you say the earth is spinning both like this on its axis and like this around the sun? We have no evidence of this. In fact, all of our empirical evidence of our experience of the world tells us that it's at rest. Aristotle, if you threw a baseball in the air and the earth was spinning, it would fall behind you. If the earth was being whipped around the sun, surely the atmosphere would have been ripped off. All of our experiences tell us we're not moving, Copernicus. I might have said Aristotle. All of our experience tells us we're not moving, and you're telling us that we are. This doesn't even make sense to us. It'd be like me saying that I am a horse. And I go around trying to convince you that I'm a horse. And you say, look, you can tell me what you want, but you're obviously a madman. Our experiences of the world and of you are not of a horse. Okay? And this is what he was trying to convince people of. So the first objection is that all of our empirical evidence of the world is not of the earth moving. The second thing is they said, look, if you put the earth in the heavens, then that means there is no real heavens. You can't have something, you can't have the quintessence anymore. If you put the earth in orbit, then the earth now has to have something like a circular nature. But only heavenly objects have circular natures. If you've elevated the earth into the heavens, you've destroyed our sort of theological framework for viewing where heaven is, where earth is, and where hell is. In a sense, you're dislocating our ability to find heaven and hell in relationship to the earth. What about salvation for other planets? They said, if the earth is just another planet, did Jesus come and die for the other planets? Are there humans on other planets? Does that mean Jesus has to be born and manifest himself to other creatures throughout the heavens? They came up with all these puzzles about what this would mean for their theology and for their philosophy and for their metaphysics if the earth was put into orbit. And what about Scripture? Psalm 93, 1 through 2. The Lord reigns, he is robed in majesty. The Lord is robed, he has put on strength as his belt. Yes, the world is established, it shall never be moved. Shall the earth be moved? No, it shall never be moved. Copernicus, you can't put the earth in motion because now the earth moves. At least this is what they complained. Moreover, Joshua 10:13, And the sun stood still and the earth stopped until the nations took vengeance on their enemies. So here, and the moon stopped. What is moving? The sun and the moon move. Under Copernicus' system, the sun is always at rest. There is no sun to be stopped. Only under something like Ptolemy or Aristotle does the sun move. So if we're going to take Joshua seriously, Joshua suggests that the sun was moving and then that it was stopped, i.e. that Copernicus' view can't be accurate. Or Ecclesiastes 1:4-5. A generation goes and a generation comes, but the earth remains forever. The sun rises and the sun goes down and hastens to the place where it rises. Right? This is a very sort of Ptolemaic Aristotelian view, not a Copernican view. And so the early church says, look, not only is your view anti to our senses, but it breaks our sort of cultural understanding of theology in terms of where heaven and hell are, and it conflicts with Scripture. We cannot accept what you're giving us. This is why the title of this section is, It's Poor Soil. This sort of medieval time in which the Copernican theory was being provided, the cultural soil was poor for the reception of such a theory. Now, I should note this. Copernicus wasn't the first one to come up with this idea. Contemporaries of Aristotle and Ptolemy also thought, hey, what if we put the earth in motion and put the sun at the center? But for similar sort of observational reasons, they rejected this. So this wasn't a new idea. Not only that, but it turns out that Copernicus' system isn't so simple. Copernicus' simple system also has a whole bunch of epicycles. And so one wonders, how much time do I have? Like 20 minutes? 15 minutes? All right. So now look at, even under Copernicus' system, you still have all these, 4 questions, yeah. You still have all these epicycles, and for what? What's the conceptual payoff? So you want to know what the conceptual payoff is? A few little small things. This. On the left is Ptolemy, and on the right is Copernicus. Ptolemy has an epicycle that is required to explain the retrograde motion. On the right, you have Copernicus, where you have the Earth now in rotation. Here, the Earth is moving around the sun. Okay, so the difference between these is subtle. One of them has the Earth stationary with the planet on an epicycle. Over here, you have the Earth moving with the planet on a regular orbit. And they both give you the same motion. They both give you the same sort of wiggly description. What Copernicus provided was a slight return to Aristotle, and an elegant solution to the retrograde motion. This is one of the big selling points. The second is, this allowed him to have more accurate calendars. People started using Copernicus merely as a calculational device. They didn't believe it at first, but they wanted more accurate calendars, so they used it. Later on, it took cultural root, and it required people to change their views of overall cosmology, overall metaphysics, overall theology. But they ended up adopting Copernicus. Now, one thing that they don't have a whole lot of time, but after this, we have Galileo. Galileo comes up with a telescope. So right now, the culture says, hey, we cannot accept you, Copernicus, because you mess up our metaphysics. You mess up our theology and our cosmology. But Copernicus gets a backup. He gets a friend. Galileo comes and gets his telescope, and he says, look, even if we don't accept Copernicus, we can't keep Aristotle's metaphysics. Why? Let's take our telescope and look at the moon. When you look at the moon, do you see a perfect, immutable, unchanging structure? No, if you look at the moon with the telescope, you see that it has valleys and mountains. It's not perfectly round or spherical or smooth, as if it was made of a crystalline quintessence material. So Galileo says, you can't claim the moon to be made of quintessence. It's not perfect. It has mountains and valleys. You get upset if you put the Earth in rotation. Why? Because now that means the sun's the center of rotation. The sun is the center of the universe. And people had a hard time with this. Galileo looked at Jupiter and said, Jupiter has 4 moons. Jupiter is a center of rotation for other astronomical bodies. If Jupiter could be the center of rotation for other objects, why can't the sun be the rotation for different things? I.e., the Earth isn't that special. It looks a lot like Jupiter. It has a moon rotating around it, and maybe they both rotate around the sun. He also discovered, other people at this time were discovering supernova. Supernova are the birth of new stars. New stars are coming into existence in the quintessence crystalline spheres. So is the heavens unchangeable? No. Things are coming into being and they're changing it. So what we end up seeing is that there is empirical evidence that is undermining the philosophical, theological, conceptual, or cosmological worldview given to us by Aristotle. And this was very painful to us. It's painful to us because it wasn't merely a revolution in the way that we viewed which planet was where. It was how it is that we viewed our overall view of reality, where we are, what our place in reality is. So I'll skip to the end here. And we are going to jump past some of these things. Kepler says you need ellipses, forces, all this stuff that we don't need to talk about anymore. And we'll go to the end. So, under Copernicus, everything became a little less special. The heavens became corruptible. The Earth lost its central place, and so did mankind. And this was a big deal for people. And then we got this again, which is just for me to say we're done. So thank you.